3, -3? How do we do that? So what happens when a line is parallel to a given line?
They have the same slope.
Yes. Parallel lines have the same slope, right? So if they have the same slope, therefore, for line 2, your n
3.
3. Then what do you need to do next?
Oh.
Ah.
Okay, so you put in that point to find B.
Exactly. Substitute 3, -3 into y equals to 3x plus b to find b. Right? So -3 equals to 3 times 3 plus b. -3 equals to 9 plus b. B is equals to -3 minus 9. B is equals to -9, 10, 11, 12, -12. So my line 2 equation is y equals to 3x minus 12. These two lines, this line and this line, are parallel. Okay?
And you can tell that just by looking at it, right? Because of the 3x.
Looking at what? No, you have to know this fact. How do we do that?
Well, right, the 3x does mean that it has the same slope, though, right?
Yes, yes. But what do you mean by I know it by looking at it?
So, like, if the equation were y equals 3x minus 5.
Uh-huh. It will still be parallel because the slope is the same.
Right. Okay.
Yeah.
Cool.
I'm running out of space. I need space. Hang on. Let me make space. Oh, this is going to be so messy. Sorry about this, guys. But I want it all in one page for you. So what if, oh, ah, okay. What if, Kara, you seem to be reading my mind. What am I going to do next?
Perpendicular.
Yes. So what if it is perpendicular? Let's do shocking pink. So we're still going to work on this one, right? So y equals to 3x plus 8 find line 2 that is perpendicular. This is a sign for perpendicular. And this is a sign for parallel. Okay, perpendicular passing through 3, -3. So what do we need to know?
Doesn't that mean that the slope is opposite?
Just opposite?
It's negative, like the negative reciprocal.
Uh-huh. Opposite reciprocal. So if line 1, M is 3, line 2, M is
-1/3.
exactly. Did everybody get that?
Yeah.
Opposite sign and reciprocal of the number. So if this is negative, then your perpendicular slope is going to be positive. Okay, these are the two things that you need to know in order to be able to do this. So then again, we're going to substitute 3, -3 into y equals to -1/3 x plus b to find b. Okay, so again, -3 equals -1/3 times 3 plus b. -3 equals to -1 plus b. b is equals to -3 plus 1. b is equals to -2. So therefore your line, your perpendicular line, line 2 is equals to y equals to -1/3 x minus 2. Question? Screenshot. Do I have any more? Do you all get it?
Yeah.
Okay, any question? Sophie? Is Sophie still here? Nick? You doing good? Good. Daniel?
Yeah.
More confused?
No?
Good. Deshaun?
Yeah, I got this.
All right. Alexa?
All good.
All right. Sophie? Whose name did I miss? Kiara, you good?
Yeah, I'm good.
Kaylee?
Yeah, I'm good.
All right. Let's continue. Next one. Parabola again. So parabola, yesterday I gave you what? 2 points, right? Is that what I gave you yesterday? Do you remember what I gave you yesterday?
I can look at it.
Was it x equals -3 and x equals 2?
Yeah, I
And
gave you 2
factor
zeros. Yes, so I gave you 2 zeros. So I wanted, the reason why I'm coming back into parabola is I want to give you like just like linear, they can give you different information and ask you to find an equation. So I just want you to be familiar with that. So if they give you a vertex and a y-intercept, how do you find the formula for a parabola?
Couldn't you put it in vertex form and then find A?
Put it in what?
Put it in vertex form and then find A.
Yeah. Yes, because they give it to you in vertex, why not just put it into the vertex form, right? So put vertex into vertex form equation. And that would be y equals to
A parentheses
y equals to a x what?
minus 1.
Minus 1. Y minus 1.
Minus 2.
Minus 2. But y minus 1? Wait, what are you missing, Kara?
It's the opposite on the inside of parentheses.
Yes, so this is positive 1. When I put it into the parentheses of x with x, I have to go the opposite sign, right? But what are you missing? Is this a vertex form?
No.
What are you missing? Somebody help her.
X minus 1 squared.
Yeah, squared. Don't forget squared. Okay, so then now, am I done? What do I do?
Solve for A
Solve for A. How do I solve for A?
with the y-intercept.
Exactly. Solve for A using y-intercept. Okay. So y-intercept. So y-intercept means this point. What is this point?
0, -5.
Y equals to -5. Therefore, the point is going to be 0, -5. So I'm going to substitute this point into this one. So it's going to be -5 equals A 0 minus 1 squared minus 2. -5 equals to, this is going to be 1, right? -1 squared is 1. 1 minus 2 is -8. So therefore, A is going to be 5. That's it. Then 3, write equation. And that will be y equals to 5, x minus 1 squared minus 2. All right. They might give you a point. It doesn't matter if this point is the origin. It could be a number. It could be an x and y coordinate with numbers. Okay, so same thing. We put it into the vertex form. So we would have y equals to a x minus 1 minus 1. This minus 1 is from x. This minus 1 is from y. Maybe I shouldn't put -1 minus. Let's change this one so that you know for sure. -2, okay? Then again, you're going to substitute the point of origin, which is 0, 0, right? Into equation to find A. So 0 equals to A, 0 minus 1, oops, squared minus 2. 0 equals to negative A is equal to 0. So therefore, your equation is y equals to, this would not be a good one. Because then everything is 0. Let me change this one. 1 minus, this will be negative 2a. So then a is going to be 2. Negative 2. No. This would not be a good one. Hang on. Negative 2a. A is 0. Let's not do origin. Let's do pass through 2, 2. Okay. So 2 is equals to 2 minus 1 squared. 2 would be 2 minus 1 is 1, 1 minus 3. What am I, goodness gracious, what am I doing? I'm not even doing this one right. Sorry, guys. This is minus a minus 2. A would be negative a is negative 5 plus 2. Negative a is negative 3. A is 3. So this is 3. Why are you not pointing out my mistake? Okay, coming back to this, 0, 0 would work. So this is 0, 0, 0. So this is a minus 3, yes?
Yeah.
Yeah. So then a would be 3. So y equals to 3x minus 1 squared minus 2. Did you see the mistake that I made?
So wait, at the put vertex into vertex form equation,
Mhm.
shouldn't the negative 2 be a negative 3 now? Because you have it as a
Ah.
negative 3 in the second part.
Why did I have negative 3? Minus 2, minus 2, a is 2. So this is going to be 2. Thank you. But did you see the mistake that I made here earlier?
Yes.
Yeah. So I kind of lumped everything together, right? I opened up the parentheses and I just straight away minus 2. But I cannot do
noticed-
that.
I noticed it as I was writing it down. I should have said something, but I just figured it was fine.
Clearly, my brain is still fried. Yesterday, I started my session at 8 o'clock. I only get half an hour break like at 2:30. No, 3:30. Before I work with you guys again. So say something, okay? Don't give up on me. Okay, any questions? Sorry about that. Yes. Okay. All right, good. Okay. Log. We're done. Oh, wait, hang on. I can do something. Let's do inverse. Another big equation. One more equation. Oh no, let's combine two things together. Inverse 3x plus 5 equals to 27, 2x plus 1. Nope, let's make it a little bit simpler. Y equals plus 3x plus 5. What am I combining? What am I trying to do with this equation?
Combining exponent.
Huh?
Combining exponent.
No, I'm actually using this problem to do more than just inversing.
I don't know, solve for x.
What happens when your variable has a What happens when your exponent has a variable? How do you solve it?
Log.
Log. So I'm combining inverse and log. So what do we do first? Do we inverse first or do we log first?
Inverse first. Or maybe not.
You think inversing it is easier first? I would log it first because then I can bring all of this down. I'm going to ground all my planes.
Okay.
Okay. So log both sides. Do you want to use log or natural log?
Log.
This is log. It's easier. Then we don't have the e to contend with either. Okay, so I'm going to have log of y equals log of 27 to the power of 2x plus 1 plus log of 3x plus 5. Can I do this? Log of y equals to log of 27, 2x plus 1 plus 3x plus 5. Can I do this?
No.
No.
Because if I'm going to log everything, right? Okay, now what? Let's make it just simpler for you. Let's just do one. So we don't have so many to deal with. Let's just do this one. Okay, now what?
You bring the 2x plus 1 in front of the 1.
Okay, log of y equals to 2x plus 1 log of 27. What can we do at this point?
Distribute the 2x plus 1.
Well, at this point, can we kind of switch x and y? We're not solving for x. We're finding the inverse.
Divide both of them.
Yeah, so now we can start working on the inverse, right? Start working on inverse. Because it's how do we work on inverse? What do we need to do first? Yes, we switch places for x and y. Okay, we switch places for x and y. So it will be log of, if it is y, we write x equal to, if it is x, we write y. We're going to switch places for x and y. And then what do we do? What's the focus here now?
Solving for y.
No, now we solve for the new y.
Right.
Yeah,
Yeah,
that's what inverse is all about. We switch, okay? So how do we do that? So we just do it like how we usually would do it. And then we're just going to solve for the y, okay? So log of x, now we distribute this, is equals to 2y log of 27 plus log of 27, yes? Because I'm multiplying log of 27 into, I'm distributing it into everything inside the parentheses. Okay, so I'm going to minus log of 27 on both sides, but I'm going to flip the equation. Can I do that? Are you guys okay with this? Let me show you what I mean. I'm going to write it as 2y log of 27 equals to log of x minus log of 27. Are you guys okay with this? I just flip it. Yeah, Alexa?
Yes.
Are you okay with me flipping the whole entire equation?
Yeah.
Yeah, okay. Sophie? Daniel?
Yeah.
Yeah, you're fine with that? Kiara?
Yep.
Kaylee?
Yeah, I'm good with that.
Okay, all right. I'm old school. I like my variable on the left side. Okay, now what do I do?
Do you factor out the y so that you get it by itself?
Well, technically, I only have one y. I don't really need, it's already factor out somewhat, right? I
Yeah.
mean, I can. If
But you
if-
can, do you divide, you could divide the other side by 2 log of 27? Is that how you would do it?
Mhm, yeah, I can factor this out. If that makes it easier for you to see, right? So then now y is by itself. Y would be log of x minus log of 27 divide by 2 log of 27. Yes?
Mm-hmm.
Okay. Can I cancel out? I have log of 27 here and log of 27 here. Can I cancel this out?
No,
No. Why not?
because the first one's being subtracted.
Yes, exactly. I'm getting in trouble. Exactly, because you have a minus sign here. So it's kind of locked in. So you cannot simplify, oh, I have a numerator log of 27, I have a denominator log of 27. I'll just cancel it and say it is log of x divided by 2. That will be wrong, okay? So once you have a minus sign here, leave it. And you're fine leaving it like that. That's your answer. Okay, so the inverse of this would be this. But if you might want to write it back into this format if you want. If they tell you to write it back into this format, if they don't tell you that, you can just leave it like that. If they say you have to write it back into this format, let's try, okay? Y is equals to log of x minus log of 27, oops, over 2 log of 27. How do I write it in this manner where I don't have any logs? Can I do that? Or simplify it into 1 log? They might say simplify it into 1 log.
Could you do log of x divided by log of 27?
Yeah, log of x over 27. And down here would be log of 27 squared. And that's as far as you can go. You can't even get it into 1 log. Okay?
Okay.
Question? Okay, let's move on. Keep time for me. 9:25, please. All right, write as single natural log of x squared minus 9 plus, 2 natural log. I just got to notice that my internet is unstable. So if I do log in and out, you can't hear me, let me know, okay? Write as a single log. How would you solve this?
Could you go back to the last slide for 1 second? I just missed one thing. Thank you. I got it.
How would you solve this? Do I need to clean anything up first?
Could you clean up and like move the 2 and the 4 to there?
Yeah.
Okay.
Good idea. So clean it up. Clean it up meaning to say that we know from the property, and please have a list of your property in case if they ask you true, false questions on just the log property. Oh, that will be an easy 10 for you guys, right? So we know from the property that if I have a coefficient in front of the log or natural log, this is actually the exponent of the argument, yes? So let's clean it up. Return the coefficient into exponent form. So I would say natural log of x squared minus 9 plus natural log of 1 over x plus 3 squared plus natural log of x to the 4th. How do I know that this 2 belongs to both 1 and the numerator and the denominator?
Because they're both in the natural log.
Yeah, because this is in a group and this is one coefficient, right? So it will belong to the whole thing. So then now what do I do? You have 3 terms. Do you want to work on all 3 terms at the same time?
No.
No, you don't want to do that, right? So maybe work on 2 terms at a time. So working on this, you will get what?
Wouldn't they be like multiplied together?
Yes, they would. So working on first 2 terms. How do you know it's multiplied together?
Is the addition in the middle?
Because that's an addition. So what would it be? Do I still have the natural log?
Yes.
Yes. Natural log of x squared minus 9 times 1 over x plus 3, oops, squared, yes?
I thought you wanted us to like distribute it.
What do you mean?
Like times them together.
Well, I would, but because I have a squared here,
Right.
because I have a squared here, it's going to be very messy unless I square everything. Because x squared minus 9 times 1 over x plus 3 squared is not equals to x squared minus 9 over x plus 3 squared. You see that?
Right.
So if I don't have the square here, yeah, I will put it this way. But because I have the square, I would not. It's just messy. Unless you want to, you know, spread this out. The question is just asking me to write it in a single log. Right? So then now I will work on, oops. Now I have 2 terms. I can work on these 2 terms, right? So it'll be natural log of x squared minus 9 times, so I have a big x plus 3 squared times x to the 4th. Am I done?
It's all in one log.
It's all in one log, and that's all that matters. If I want, I can clean it up because this is by itself. I can clean it up and say x to the 4th, x squared minus 9, 1 over x plus 3 squared.
Okay. Makes sense.
But if I want, I can actually kind of put it all in one because 1 squared, so 1 plus 1 over x plus 3 squared is actually, oops, I said squared, is actually 1 squared over x plus 3 squared, yes?
Yeah.
That's the same thing, right? Which is actually 1 squared is 1 over x plus 3 squared. So if I want, I can actually put it all together. Then if I put it in this form, x to the 4th times x squared minus 9 times 1 over x plus 3 squared, can I put it as x to the 4th x squared minus 9 over x plus 3 to the squared? Would that be the same thing?
Yeah.
Yeah. So if I want to, I can do that. But you have to be very careful when the whole thing is squared. If you absolutely have to break it down like this, break it down like this, because if this is not 1, it changes things. Then, you know, there'll be a number here. X to the 4th, x squared minus 9, all over x plus 3 squared. And it looks nicer that way too. Should write my 4 smaller because it's an exponent.
So technically, those last 3 lines right there are all the same answer.
Yeah.
And we would be
Yeah.
okay without distributing that, right? We don't need
Say that again, Daniel.
that last part. We don't necessarily need to do that. It doesn't say specifically do.
It depends on what the question is saying. If the question just say write a single log, this is good enough.
Right.
If the question says write a single log as 1 term, then you have to come all the way here. Okay, so it really depends on the question. Do I know what the question is going to be asking? I don't. I'm giving you all scenarios. Okay. Okay, I want to do one more inverse, but using regular equation, and that is not log, so you guys can actually see what is really going on. Would that be a good idea?
Yeah.
Okay. Okay, while I'm writing, let me ask you this. If I give you a graph and I ask you to inverse this graph, what are you going to do?
You would pick points and this one. Okay.
What's that? A graph is drawn for you and you are asked to inverse this graph. What are you going to do?
Find the points of it.
Find all the points. There's no equation, just a graph.
It would be the. It is the negative.
Okay, Daniel,
I
you
know.
sound very muffled.
You change the signs on the points, right?
Yes. So what you do is when you are given a graph and you're asked to inverse the graph, what you do is, what you're going to do is just switch the X values to Y values and switch the Y values to X values.
Oh, that's not
Okay, so this X and Y values are from the original graph given. No graph given. Once you switch this is going to be the inversed graph, right? So if this is 1, 2, 3, and or 1.5, right? 4 and 2. Okay, so what you do is that you just switch them. So if 1, 2, this point here is going to be 2, 2, 1. So this point is going to come here. Okay, 4, 2 is going to be 2, 4. This point here is going to come here. You see that? And then all you have to do is just draw the graph according to this new point. Then draw the new graph. And that will be your inverse graph. Don't have to do calculation or anything. Just pick the points, okay? If you have to, you will say X, Y, okay? Points on graph. Inverse points. So you have 1, 2, 2, what? 2, 2, 1.5. This is 3. So 3, oh, I don't know, 2, for example. Okay, this is not a function. I know I have 2 same output. So say this is 3, 3 or 3, 4. Okay, this is the points from the original graph that you pick up. So this is going to be like 0, and then you have this one as -2, 0, right? So your inverse point, you're going to write your X and your Y, your new one is going to be 2, 1, 1.5, 2, 4, 3, 0, -2. And this is the graph that you're going to be drawing on top of this graph to show the inverse, what the inverse graph look like. Does that make sense?
Yeah.
Okay. You draw this graph, this one. This is going to be your inverse graph. So what you did was you just flip-flop the 2 points here from the original graph, and you're going to draw a graph using these new points. That's it. That's your inverse graph. That can worth 10 points.
Hey, Annie, it's
Yes.
9:25.
Okay. All right. So let's do the inverse for this equation this evening. Okay. We'll do the inverse for that equation this evening at 5 o'clock. I'll see you again at 5 o'clock. We'll start with there.
Okay.
But you all got how to do the inverse graph, right? If you're given a graph and asked to inverse.
Yeah.
Okay. Pick strategic points, switch them, and draw. That's it. 10 points. Easy 10 points. I'll see you all this evening. Thank you so much for coming. 2, 4,
Thank you,
6, 7.
Annie.
Thank you. Bye.
Bye.